Hi guys, today we're going to demonstrate how to do molar volume of a gas experiment. This experiment consists of generating hydrogen gas using metal magnesium ribbon and concentrated hydrochloric acid. Magnesium ribbon has to be very clean. Okay, so if you look at this magnesium ribbon right now, it has black material on it. That's magnesium oxide. What we want to do is we want to make sure that magnesium is cleaned and it's all silvery and there are no oxides, magnesium oxide or magnesium nitride on the magnesium. This can easily be done using steel wool, what we clean our pots and pans with. Okay, so what I do recommend is the following, is you can use the top of your ring stand, put a piece of paper towel on it so you don't scratch your bench or you scratch the pad, and in one direction hold down the magnesium and clean it. Okay, now we have to clean both sides, okay, both sides of the magnesium. So now I will do the other side, and then I will also flip it over to do the other. And you will see, I will show you in 1 minute once I'm done. Okay, actually I will clean half of this. Okay, so if you guys look, right now, one side is shiny, the other side is not shiny. Okay, you want to make sure that everything is as shiny as this side right here. Okay, so I'll continue cleaning this part that is not, it still has magnesium oxide on it. Okay, so once all of the magnesium oxide is off and the magnesium is cleaned, what we will do is we'll get an accurate mass of magnesium. So the magnesium has to be weighed after cleaning, not before. If you weigh it before cleaning, then you get the wrong mass of magnesium. We want the mass of pure magnesium. So we will use a 4 decimal place analytical balance. Okay? And the magnesium ribbon has to be between 70 milligrams and 85 milligrams. It cannot exceed 85 milligrams because then we will have too much gas and we will not be able to get an exact volume using a odometer that I will discuss in 1 second. Okay? So let me make sure this is 0 first. And I have 81.3 milligrams. So that's the mass of my magnesium, 81.3 milligrams or 0.0813. Our next part is I'm going to turn this into a small ball, into a small magnesium ball. So I'm going to wrap it. Just bend it and form something like this. Okay. If the magnesium is good, it will not break from you. If the magnesium is brittle and it breaks, you have to find a better piece of magnesium. Okay. Next, we will get about a 20 centimeters piece of copper wire. And we're using copper wire because copper does not react with hydrochloric acid. So when we put magnesium and hydrochloric acid, it will react to produce hydrogen gas, but copper does not react on hydrochloric acid. And what I will do with the copper wiring is I will build a cage to surround the magnesium. This way, in case it starts to disintegrate in the reaction, I make sure that it's trapped in such a way that all of it gets reacted and none of it gets stuck to the side of the iodometer. So the first part I do is I form a small little bend like this, and I start to twist and turn the copper in all directions. Just be careful you don't hurt yourself. Okay, do it slowly and gently. So first I'm going to wrap it in one direction. And it's exactly, you're building a cage to trap the magnesium. That's all it is. Okay, and then you want to turn to different directions just so in case it starts to break, it doesn't escape the cage. It remains inside the cage. And if you see places that are like this, that need a little bit of copper wire, you could always turn the copper in that direction to cover it. Just like I'm doing right now. Okay. And you want to leave a small piece of copper like this, where we're going to turn that into a hook so it doesn't fall into the iodometer. So basically, that's what you want to form. So we have a copper cage, and inside the copper cage, we have our weight magnesium ribbon, and we weight this on a 4 decimal place analytical balance. Okay. The next part is we're going to create, or we're going to generate hydrogen gas using an instrument called the iodometer. The iodometer is basically a big test tube, okay, that's graduated, and I could record the volume of a gas on it. Now this is upside down, of course, because the gas will be generated up on top to push all the liquid out. So this here is 100 ml iodometer. Here is the 0. This here, where my thumb is the 100 line. And between each 2 mLs, there are 10 divisions. Each division, or each line, is 0.2 mLs. So we could read the volume quite accurately on this iodometer. Okay. I will generate hydrogen gas over water. So I should get a 600 ml beaker. I will fill it halfway or maximum to the 350 line, because once I generate the gas will push out all of the liquid, all of the solution that's inside the iodometer. And if I don't leave space in the beaker, the liquid that's going to push out will not have space in the beaker, and it would flood. Okay, and I'll have a flood on my bench. So just make sure that maximum reach the 350 line. Okay, next, the reaction is going to require 20 mLs of concentrated hydrochloric acid. Okay, now hydrochloric acid is in excess. Okay, our limiting reagent is magnesium. So it's okay if I don't measure exactly 20 mLs. If you go a little bit over 20 mLs or a little bit below 20 mLs, remember, we have excess hydrochloric acid, so don't worry about it. I will get a 50 ml graduated cylinder. The hydrochloric acid will be under the hood, so I will go to under the hood and obtain 20 mLs of hydrochloric acid. Hydrochloric acid bottles are usually in coin stoppers. Okay, you should not put the coin stoppers down on the bench or down inside the hood. You should hold it in your hands. So let's go to the hood right now. I'll demonstrate how you should handle a coin stopper. So what we're going to do is, using these 2 fingers, I will hold the coin stopper in my hand. So this way I don't put it down and it gets contaminated. I will then, with my hand, hold the hydrochloric acid bottle, and I will measure around 20 ml of hydrochloric acid. And then you put the coin stopper back on. Be very careful with hydrochloric acid. Okay, it's a very strong acid and this is concentrated. Okay, so if you get any on your hand, immediately wash your hands with soap and water. First dilute the acid, followed by washing your hands with soap and water so it doesn't burn your skin. And of course, always keep your safety glasses on. Okay, so I'm gonna pour my 20 ml of hydrochloric acid inside the odometer. Now, hydrochloric acid is much denser than water. And here is a very important step of the experiment. Okay, we want to make sure, okay, that we keep the hydrochloric acid down here, okay, and control the experiment, okay, and not have the acid mix with the water. This way I don't have a dilute solution of hydrochloric acid, because if I have a dilute solution of hydrochloric acid, once I put my magnesium ribbon, it will react, it will produce hydrogen gas that I will not account for. So it is very important to add water very slowly to the odometer. Now what I like to do is I like to set the odometer on the bench, tilt it, get a wash bottle with deionized water. Remember, everything has to be deionized water. First, I'm going to squirt a little bit of water inside the odometer and turn the odometer. This way the water washes the sides of the odometer. Okay, this way all of the acid that's on the side will get washed down. And if you guys focus on the interface, you will see that there will be mixing occurring. Okay, so I'm going to turn this, okay, and I'm going to wash. And if I remove this paper towel, okay, the black will give you a better contrast. You'll see there's mixing occurring, but I continue to tilt the odometer and I slide the water slowly. At the interface, water will mix with the concentrated hydrochloric acid, but eventually the mixing will slow down. Okay, and after it slows down, it will cease and it will come to a stop, and water will just slide on top of the hydrochloric acid, and the top of the odometer will only consist of water alone. Okay, now of course we're going to test this after we're done to make sure that we did not mix the hydrochloric acid. Okay, and that we will do by putting magnesium into the solution and see if we produce any bubbles, any hydrogen gas or not. Okay, so we will continue. If you guys look right now, I don't see any mixing. Okay, so I believe the hydrochloric acid is at the bottom of the odometer, and the top of the odometer only has the deionized water that I'm using to fill it. Okay. We could stop right here. We'll use a burette holder to hold it, and now I'm going to test. I'm going to take, this is the reason why I made a hook with the copper. Okay, I'm going to put this magnesium in a cage inside the solution. Now I slide all of the water down the odometer, so down here I should really have my hydrochloric acid, and up here should be water. So if I did this correctly, once I put this inside, I shouldn't find any gas being produced. If I find gas being produced, I would have to repeat the entire procedure over, because now I'm producing gas that I cannot account for. So let's give it a try and see. And if you look, you see that there is no reaction, and this solution right here is water. Okay, so we are actually good to go. So the next thing I want to do is I want to get a 2-hole rubber stopper. Okay. Next I want to get a 2-hole rubber stopper. Okay, and I want to fill this eudometer all the way to the end. Okay. Now don't worry if some of the water comes out of the eudometer, because it should be water. Okay. Next thing I want to do is I want to put the rubber stopper inside. Make sure there are no air bubbles. I found one air bubble. I'm going to take it out. Okay, I'm going to refill with water. Okay. Don't worry, this water that's coming out is only water. It's not acid. Okay, next, you want to make sure the system is air-free. It doesn't have any air. So using the 2-hole rubber stoppers and my water bottle, I will fill up all of the holes with water just like this. Okay, this way right now I don't have any air at all in my system. Okay, next, what I will do is I'm going to set up my beaker. I will put my index finger, and be careful, it has to be your index finger, over the holes. Invert the eudometer upside down. You could see the mixing occurring. Don't let go of your finger. The eudometer is going to get warm. Put the eudometer, submerge it underwater. Once it's underwater, you could let go, but do not let go before. Okay, and then you could set it up. Okay, make sure the eudometer is not touching the bottom of the beaker. Okay, if you look, it's not touching the bottom of the beaker. And now all of the hydrochloric acid that was on the top of the eudometer started to go down. It already started to react with the magnesium. And if you look closer, you will see it reacting with the magnesium on top. The hydrochloric acid is still mixing at the bottom. The hydrogen gas is reacting, is being produced, is being captured on top of the eudometer, because the gas is less dense than the water and the hydrochloric acid. So 3 different densities we have right now. We have hydrochloric acid was the most dense. That's why it stayed at the bottom of the eudometer, followed by water. And of course, the gas that's being produced right now, hydrogen gas, it's a gas, so it's less dense, and it's traveling to the top of the eudometer. The reaction will continue, and if you look at the bottom of the tube, you see the liquid being pushed out, and that's why we don't have we don't have the rubber stopper resting on the bottom of the beaker. It should leave it a little bit this way. All of the solution that's being pushed out of the eudometer goes into the beaker, and you notice how the volume of the beaker starts to increase. Okay, and this is the reason why we have to make sure that the beaker is only half full. The reaction will continue. Now this is a very exothermic reaction. So if you feel the eudometer, okay, it's very warm, okay, and the reaction seems to have stopped. There's always a little bit of air, of hydrogen gas that you see at the bottom of the eudometer, especially on the copper wire. You could hold the eudometer in your hand and gently tap it to bring up all of that hydrogen gas. Okay? Now, the reaction that occurred here, okay, we're going to look at it later, but this is magnesium ribbon. with hydrochloric acid. It's a single displacement reaction. It's also a redox reaction, because all single displacement reactions are redox reaction. So the magnesium oxidized and the hydrogen, the proton from the acid got reduced to hydrogen gas. And this is right now I have hydrogen gas produced over water. Okay, now if we look, there are the atmospheric pressure. Today's atmospheric pressure is acting on the beaker, okay, and it's being opposed by the hydrogen gas that's inside the odometer, followed by water vapor, because I'm collecting all of this gas over water. So there's water vapor inside this gas that we also will need to account for, as well as, if you look closely, the water column, there's a water column. Now, this is not the right time to take measurements for this. Because the reaction is exothermic, you should really leave it for 10 minutes, okay, to cool down. When you allow it to cool down in 10 minutes, what ends up happening is the whole system cools down and it's equal to its surrounding. Okay? Right now, one of the measurements that I need to take is the measurement of hydrogen gas. Now, this can be done with an analog alcohol thermometer or a digital thermometer. Right now, the reaction is exothermic. The gas is warmer than the outside. I cannot put the probe inside to measure the exact temperature of gas. So it's recommended, it's highly recommended that you wait 10 to 15 minutes to allow the system to cool down and be in equilibrium with the air surrounding it. This way we could take better measurements, okay? And during that 10 minutes, you'll find that the volume of the gas will change, as well as the length of this column. But we'll come back in about 10 minutes to take the measurements, and we'll discuss the calculation in a later video. Alright guys, so now we're back. It's been over 10 minutes, so the system has cooled down. It should be in equilibrium with its surroundings. And before we start taking measurement, I just want to explain what we see up here. So right now, the surface, the water surface, it has the atmospheric pressure acting on the water surface inside the beaker. The atmospheric pressure is being opposed by everything that's inside the odometer from the surface of water up. And from the surface of water up, if we look closely, we begin with a column of water that's still inside the column, followed by gas. And inside that gas, this is not dry hydrogen. Remember, I had mentioned earlier, we're collecting hydrogen gas over water. So inside here, I have the pressure of hydrogen gas plus the pressure of water vapor, plus the pressure of this water column. Okay, so when we start to do the calculations, we're going to learn about Dalton's law of partial pressure. It's a very easy law. It states that the total pressure, which is the atmospheric pressure acting on the surface of water, is equal to all the partial pressures. What are my partial pressures? Well, the partial pressures are the pressure of the hydrogen gas inside the odometer, plus the pressure of water vapor, plus the pressure of this column of water. If this column of water was to the surface, okay, then I would have a higher pressure of gas inside the odometer. That's why it would push the liquid further down. Right now, the pressure of hydrogen gas and the pressure of the water vapor is less than the atmospheric pressure, and this is the reason why I have a column of water. So let's start. Okay, we already measured the mass of magnesium earlier. The next item that we need to measure on your data sheet is the volume of hydrogen. Now, since the odometer is already graduated, I could read the volume of hydrogen right off the odometer. Now, the odometer that I have the graduated writings and the graduated numbers in white letters. Okay, so I could use a black background to read the volume carefully, and if it's in black letters, you could use a white background. So just remember that your eye has to be at the meniscus level. We can't look down at the meniscus. We can't look up at the meniscus. So I'm going to bring my head down and I'm going to read the volume. And here I have, this is around 82.2 mLs. So I have 82.2, it's actually right on the 2 line, so I'm going to call this 82.20 mLs of hydrogen gas. Next is I need to take the temperature of gas, so I'm going to use a digital thermometer. Now, the system's been, and the reaction's been sitting in the air for quite some time now. We actually let it sit for more than 15 minutes. So the air inside the odometer should have equal temperature as the outside. Right now, because I'm still taking my measurements, it's very difficult to take the probe inside the odometer and measure the temperature. So what I will do is I will put the probe right next to the odometer and I'm going to measure, and here I'm measuring room temperature, which should be the same as the temperature of gas, and this is 24.2 degrees Celsius. Okay, and right now it just went down to 24.1. Okay, so right now I will record it as 24.1 degrees Celsius. Okay. Next is we need the temperature of water, because the temperature of water is very important, because I'll be able to determine what the pressure of water vapor is inside the odometer. High water temperature means there's high vapor pressure. Low water temperature means low vapor pressure. So to check the temperature of water, I will put my thermometer inside the beaker with water, and here the beaker is a little bit warmer than the air, so right now I'm at 25.0. It's still climbing, it's 25.1. So I will continue to wait until I reach the maximum temperature. Once I reach the maximum temperature, the temperature stabilizes. So now my temperature stabilized at 25.2 degrees Celsius. The next is the barometric pressure. Okay, for the barometric pressure, because we don't have a barometer in the lab, what we're going to do is we're going to use weather.com. Okay, and I'll show you that in the calculation video, how to obtain the pressure. The pressure on weather.com depends, of course, on the zip code and is usually given in inches of mercury, but we could convert inches of mercury to millimeters of mercury, and that will be shown later. The last piece of data that we need to collect is the difference in water level that's inside the odometer. Now this we're going to measure from the surface of water in the beaker to the meniscus up where we measured the volume of the gas. So this should be measured in centimeters. Okay, it'll be much easier to measure in centimeters, and then after that convert to millimeters of water. Okay, now remember that the beaker is not sitting, or the odometer is not sitting at the bottom of the beaker, so we could always move the beaker in case we need to get a better angle. Okay, you want to make sure that the surface of water is at the 0 centimeter and measure to the meniscus. So we're gonna first set up And this here I'm reading 17.95 centimeters, and I will repeat to double check. Yes, 17.95 ml. So that's 179.5 millimeters. This is all of the data that we need to collect. I will see you guys in a later video to show you the calculations for the experiment. Okay, now that the experiment is done, everything that's inside the beaker is non-hazardous waste because this is a combination of magnesium chloride and dilute hydrochloric acid. So we could just lift up the odometer to empty out the water column that's in there. Once all of the liquid is emptied, the rubber stopper is reusable. This copper wire is also reusable, so we should untwist to get ready to use for another experiment. Copper is kind of expensive, so we don't want to throw it out, and it's good for many experiments. Okay, so we should unwind it just like this. Just be careful while you're doing it. You don't want to hurt yourself. Okay. And you can return it back to the way it was. Okay. And this liquid, I will go to the sink and throw it out in the sink. Just flush it with some water. Now you're ready to do the second trial. Okay, you just need to obtain another piece of magnesium, clean it, weigh it. Also, you need to refill the beaker with water and repeat the experiment again.